Hello friends, welcome to Engineer Babu. Today we will be doing surveying. So we will not go into the detail of the subject. So let's just start with the subject. The first one is the definition of the survey. Survey is the art of determining relative positions of the points on, above, or beneath the Earth's surface by means of direct or indirect measurements. Now there are two types of surveys, plane survey and geodetic survey. In the plane survey, we will not consider the effect of curvature of the Earth, and in the geodetic survey, we will consider the effect of curvature of the Earth. Now, the land survey is divided into three parts: topographical, cadastral, city survey. Now, topographical, in this, general topography of the region is being studied. For example, whether it is a hill, valley, etc. And in cadastral survey, property lines are being studied. And in the city survey, general sewer, pipelines, general services in the city are being studied: sewer, electricity, water, pipelines, etc. Now, what are the principles of surveying? Surveying has two principles. First one is working from whole to part. It is from whole to part. And the second one is location of a point with respect to the two references. Now, what is scale? Scale is the ratio of map distance to the ground distance. It is a technique through which ground distance is being represented on the paper. Now, general geographical scale that is being used is 1 centimeter is equal to 5 kilometers to 160 kilometers. Representative factor is map distance upon actual distance. It is almost same as that scale. Now, representative factor is also map distance upon actual distance. Now, the scale is the technique through which ground distance is represented on paper, and it is the ratio. So now, if RF is more, then the scale will be less. For example, suppose if we have RF 1 centimeter is equals to 20 centimeters, so RF will be 1 by 20. So if this value is low, then we will call it a bigger scale. So that's it. Now coming to the Vernier scale. Vernier scale is the secondary unit of main scale. Vernier scale is the secondary unit of main scale used for exact measurement. Exact measurement will be equals to main scale reading plus Vernier scale reading. Now, type of verniers. There are 4 types of verniers. The first one is direct vernier. In this, Vernier scale division is smaller than the main scale reading. So in this, n-1 main scale readings are equals to n divisions of vernier. The next one is retrograde or indirect vernier. In this, Vernier scale divisions are greater or larger than the main scale reading. In this, n+1 divisions of main scale are equals to n divisions of vernier. The third one is double vernier. In this, there are vernier on the both sides of 0. For example, like 0 is here, this side also and this side also, both sides. That's why it is called as double vernier. In the extended vernier, 2n-1 divisions of main scale are equal to n divisions of Vernier scale. Now, shrunk scale. Shrunk scale is equals to shrinkage factor into original scale. Now, what is shrinkage factor? Shrinkage factor is equals to shrunk length upon original length. Now, coming to the chain survey. These are various types of lines in a survey. So these are the main stations. These A, B, C, D, E. These are the main stations, and this one is the baseline, the line dividing the whole survey, closed survey, into almost 2 equal parts is the baseline. And these are the main survey lines connecting to all the major stations, main stations. And this is the tie line that is used to locate any object or any place in between the survey. And check line are used for the accuracy of work. Now, instruments used in chain surveying: chain or tape, pegs, arrows, ranging rod or offset rod, 90-degree angle measuring devices, and clinometer. Now, 90-degree angle measuring devices are these: cross staff, prism square, and optical square. In these three, optical square has the highest degree of precision, then comes the prism square, and in the end comes the cross staff. And clinometer is ground slope measurement, is used for ground slope measurement. It is slope measurement device. Now chains, there are 4 types of chains. First one is metric chain. 3 types of metric chains are there: 20 meter, 30 meter, and 30 meter with 100 links, 30 meter with 150 links, 20 meter with 100 links. Now the second one is Gunter's chain. 66 feet is the length and 100 links. Engineer's chain, 100 feet length and links are 100. A revenue chain, 33 feet length and 16 number of links. Now coming to the tape, there are 4 types of tape. The first one is cloth or linen type. It has mesh type of structure, actually, this type, cloth or linen type. The second one is metallic tape. The metals are brass, copper, and bronze. Steel tape. Then comes the invar tape, alloy of nickel. This one is most widely used and best of all these 4. These are the representations of chainage. Now we can represent chainage in any of the following ways. First one is 50 chain and 60 link directly. We can write this. Then we can write like this: 50 plus 60 chains. These are 50 full chains and 60 links. Same here, 50.60. And in terms of distance also we can directly write it. Now the corrections used in the chainage. First one is due to the incorrect length. L is equal to L dash upon L into L small l dash. Now L is the true or the designated length of the tape. That is like we say that a 30 meter chain is found to be 1 centimeter long, then the true length will be 30 meter because it was the designated length. L dash is the wrong length of the tape. Small l dash is wrong length of the line measured. Small l is the true length of the line measured. In this there is a simple rule actually. Right into right is equal to wrong into wrong. We can use this to solve the problems. Similar for the area, L dash upon L whole square into A dash. For volume, cube will be there, L dash upon L cube into V dash. Now the slope, correction due to slope. Now this is the correction due to slope: L dash minus under root L dash square minus H square. This is the basic diagram actually. Exact relation. This is the exact relation, and generally for the MCQ purpose we use this relation. Correction due to slope is equal to H square upon 2L dash. Now correction due to alignment. Correction due to alignment is L dash minus under root L dash square minus H square. Similarly, this is also the exact relation, and the relation that we use for the MCQ purpose is H square upon 2L dash. Now the correction due to pull. Correction due to pull is PM minus P naught into L dash upon AT into ET. P naught is standard pull. PM is the pull at the time of measurement. L dash, and we have seen earlier, AT is the cross section area of tape, and ET is the modulus of elasticity of the tape. Now the nature of the correction. If PM is greater than P naught, then correction will be positive. If PM is less than P naught, then correction will be negative. Correction. Now the next one is correction due to sag. This is always negative correction. This slope correction will also be negative always. These are slope and sag are the 2 corrections that are always negative in nature. Now the sag correction is W dash capital W square L dash upon 24 PM square. Or we can also use it like C sag is equal to W small w square L dash cube upon 24 PM square. Capital W is the weight of tape or chain, and small w is the weight of tape or chain per meter length. So basically capital W is equal to small w into L. Put it here and you will get this relation. And yes, normal tension is when correction due to sag is equals to correction due to pull. These both these corrections neutralize the effect of each other. That is called normal tension. Temperature correction, temperature is L dash alpha Tm minus T naught. When Tm is greater than T naught, then it will be positive. When Tm is less than T naught, then correction will be negative. And the next one is reduction to mean sea level. This correction is basically not used that much. It is also negative in nature. Now this is L minus D. This is the L length, and this is the D at MSL, radius H, distance. So basically it is CRML is equal to L into H upon R. Now the limiting length of offset. Basically limiting length of offset is that how much length should be there of offset that it will not show any error on the map. So there are two cases of limiting length of offset. First one is when error in laying direction only, and in that condition L is equals to 0.025 s upon sin theta. And the second case is error in direction and length measurement. P, actual point on the ground, P1 point located on the map, theta is the error in laying direction, x is error in length measurement, P2. Now for the second case the relation is L is equal to 1 upon sin theta under root of 0.025 s whole square minus x square. If accuracy in linear measurement is 1 in R, then total error in the offset length measurement x is equals to 1 upon R into L. So that is equals to L upon R. Now bearings, horizontal bearings are the horizontal angle measured of a line with respect to fixed direction, that is called meridian. Now there are two systems of bearings, whole circle bearing and quadrantal system of bearings. Whole circle bearing and quadrantal. In this whole circle bearing we represent the bearings as it is. For like if the angle is, this angle is theta A and its value is like 60 degree, then it will be shown as 60 degree. And these are the two representations of WCB and QSB. In this, reference is north. From here all the angles are measured, and in this north or south, from here and here both ways we can measure the angle, and here the direction is always clockwise. In this anti-clockwise also we can measure. In that case we have to write 90 minus theta, limit 0 to 360 as it is, we have to represent the angle, and in this 0 to 90 degree is the limit representation. Theta is the representation of this, and here we represent the bearings as north theta degree east, north theta degree west, south theta degree east, south theta west, like this. For example, for this theta b will be this for this b dash bearings will be represented as south theta b east. So now true meridian. True meridian is the line joining true north and south poles of Earth along the curvature. True bearing, horizontal angle measured with respect to true meridian. Magnetic meridian, direction of magnetic flux on Earth's surface connected magnetic north to magnetic south of Earth is called magnetic meridian. Magnetic bearing, horizontal angle measured with respect to magnetic meridian. Magnetic declination, horizontal angle between true meridian and magnetic meridian. It is variable and change is called variation. Now the type of variations. There are 4 types of variations: daily variation, secular, yearly and irregular. Secular is generally seen for 250 years. Irregular variations don't have any time limit or boundation. Yearly variations on annual basis, daily variations daily. Type of declinations: easterly declination and eastern declination and western declination. Eastern declination is when magnetic meridian shifts to the east of the true meridian, so that will be the eastern declination, and if it shifts to the west side, it will be western declination. Like here, theta E is the eastern declination. This is the western declination, theta W. Now here it is the true north, true south, true east, true west. This is the true meridian, and this is the magnetic meridian. This is magnetic north, magnetic south, magnetic east, magnetic west. Now this has shifted towards the east, so this is the eastern declination. From magnetic meridian, this bearing is called magnetic bearing, and from the true meridian, bearing of this line A is called as true bearing. True bearing will be, in this case, for the eastern declination, true bearing will be theta magnetic bearing plus eastern declination. For western declination, it will be true bearing equals to magnetic bearing minus theta W, western declination. Now dip angle or angle of dip. It is the vertical angle of magnetic flux direction with respect to horizontal direction at any place. At poles it is 90 degree, and at equator it is 0 degree, like this. It is 0 degree here, and it is 90 degree with this 90 degree here. Now measurements in compass survey. Traverse. There are open traverse and closed traverse. This is open traverse, it is open-ended. This one is closed. Measurements are taken like this. In the forward direction, this is fore bearing. Bearing taken in the direction of traverse, back bearing. Bearing taken in the opposite direction of traverse. And the difference of fore bearing and back bearing should be 180 degree. If fore bearing greater than 180 degree, then back bearing will be fore bearing minus 180 degree. And if fore bearing is less than 180 degree, then back bearing is equals to fore bearing plus 180 degree. This one is the fore bearing of line A, and this one is the back bearing of line AB. Local attraction. Magnetic objects found near a station that can deflect a magnetic needle from exact magnetic north, making bearing erroneous. Means error is there. And in this case, if local attraction is there, for difference of fore bearing minus back bearing will not be equal to 180 degree. Now methods to solve local attraction for a closed traverse. There are two methods: direct method and internal angle method. We will not go into the detail of those. Now, latitude and departure. Departure is this component, horizontal component of the line, and latitude is this component. Angle is measured from north. These are the quadrants where showing the nature of latitude and departure. In this quadrant, latitude is positive, departure positive. Here latitude negative, departure positive, so on. For closed traverse, summation of latitude should be equal to 0, and summation of departure should also be equals to 0. This is kind of check. Now closing error. Closing error for latitude and departure. It is equals to E equal to under root of EL square plus ED square. EL is error in latitude, ED is error in departure. Direction of error. Theta is equal to tan inverse ED upon EL. Methods to solve closing error. Bowditch method. In this Bowditch method, both the angular and linear measurements are equally precise. correction is equals to correction in latitude is equals to minus whole L1 small l1 upon summation of L into summation of L. This is the length, summation of the lengths. This is the latitude. Second one is the transit method. In this, angular is more precise than the linear one, linear measurement. Now the correction is minus of L1 upon LT into summation of L. This is error in latitudes, summation of error in latitudes. This is the sum of latitudes. This is the latitude of that point. This is reduced. Next one is reduced level. Height of a point with respect to mean sea level. Benchmark. Fixed location on ground surface of known RL. Backside reading. All first readings taken after setting up the instrument at any location. Foresight readings. Last reading after which instrument is either shifted or work is closed. Intermediate sight readings. All other readings except foresight and backside. Methods to calculate RL. Height of instrument method and rise and fall method. In height of instrument method, height of instrument is equals to RL of benchmark plus backside. RL equals to height of instrument minus intermediate sight or foresight. Now the checks used in these methods. Summation of rise minus summation of fall should be equal to last RL minus first RL should be equal to summation of backside minus summation of foresight. Now these two checks are used for the height of instrument method, and all of these three can be used in rise and fall method. So this one is more accurate. Corrections in leveling work due to earth curvature. Correction due to earth's curvature. CC is equals to minus d square upon 2r, or we can solve it. It comes out to be CC is equal to minus of 0.0785 d square. D is in kilometers, and this correction will be in the meters. D is the distance between staff and instrument. Second one is due to refraction. It is 1/7 of correction due to curvature. This is positive. This one is negative. This correction due to refraction is equals to plus 0.0112 d square. Now there is combined correction due to curvature and refraction. C is equals to minus of 0.0673 d square. D is in kilometers. Distance of visible horizon. The maximum distance up to which Earth's surface is visible from a certain height. D equals to 3.855 under root of h1 plus under root of h2. This is the distance with corrections. There is only one tower, then the second term will not be there. It will be just like 3.855 under root of h1. Now reciprocal leveling. It is done when there is an obstruction in the direction of survey and fly leveling is not possible at all. Nearby obstruction like river or valley. Error due to curvature and refraction are eliminated in this reciprocal leveling. H, the formula is this is H is the height difference between the 2 points. HB minus HA plus HB dash minus HA dash upon 2. Now H is the height difference between A and B. This one. HA and HB are the readings taken when instrument is at A. HA dash and HB dash are the readings taken when instrument is at B. Final RL of B will be RL of A plus minus H. This H. Inclination or collimation error. Collimation error is equals to HB minus HB naught. This one. HA plus these are the values. Theta is equals to tan inverse HA plus H minus HB naught upon D. This is the theta here. Sensitivity of bubble tube. Alpha. Sensitivity is an angle of rotation of bubble tube due to one division moment of bubble. Alpha is equals to theta upon n is equals to s upon n. D is equals to L upon R into 206265 seconds. Theta is the rotation given to telescope. L is the length of one division of bubble tube. N is the number of divisions, D is the distance of staff from instrument, R is the radius of curvature of bubble tube. Now, important thing, factors on which sensitivity of bubble tube depends. Radius of curvature directly, diameter of bubble directly, length of bubble directly, viscosity of liquid in tube indirectly, finishing texture of tube's internal surface, means whether it is smooth or rough, directly with the smoothness. Temperature, very important. With the temperature it varies indirectly. Now contours. Contours are the lines joining points of equal elevations, that is RL of those points is same. Contour interval, difference of levels between two consecutive contours in a map. It is vertical actually. Vertical distance. For example, hill contour increases towards center, and for valley or pond it decreases towards the center. Now these are the two exceptions in the contour. In this, they seems to contours never, this is the property of contours, that they never cut each other. Or in this vertical cliff they seems to be joining at single point, this like this. This is due to the geometry of this vertical cliff, and here they seems to cut each other, but they are not cutting each other. They all are different contours. Trigonometric survey. The first case is when distance can be measured. Here RL of this point P will be equals to RL of benchmark plus H this one, plus D tan theta, this is the value of V, plus C is correction. The correction. Now the second case is when distance cannot be measured. In this case, D will be equals to B tan theta A minus S upon tan theta B minus tan theta A. V is equals to D tan theta B. S is equals to HB minus HA, and the resulting RL of P is equals to RL of benchmark plus HA plus S plus V plus, this is correction. Now the third case. Generally for SSC only two cases are required. This one is for the ES or gate, when distance cannot be measured and all 3 points are not in the same vertical plane. This side view is same for this also. This one is the top view. Top view for same. For that, for this diagram only, this one is the top view, this one is the side view. For different case. Now to solve this we have to use sine and cosine rule. Tachyometry. Tachyometer is a special theodolite having crosshair with 3 horizontal lines by which 3 staff readings are taken. We can calculate horizontal distance with the help of this. This is the basic diagram of the telescope and all the parameters are there. This is the tachyometric equation, basic tachyometric equation. D is equal to Ks plus C. K is the multiplying constant which equals to F upon I. F is the focal length, I is this distance. C is the F plus D, it is additive constant, this one, F plus D. This is the basic diagram of lens, how it works. An electric telescope is the one for which the value of K is equals to 100 and C is 0. Now in this also we have sub cases. Case 1, when staff is kept vertical. We will not study the cases but just jump to the conclusions. Horizontal distance for the angle of elevation. Horizontal distance D is equals to Ks cos theta plus C cos theta. V is equals to Ks cos theta plus C sin theta. For angle of depression, D is equals to Ks cos theta plus C cos theta. V is equals to Ks cos theta plus C sin theta, same. Now second case, when staff is kept normal to line of sight. For elevation, d is equal to ks plus c cos theta plus s2 sin theta. V is equals to ks plus c sin theta. For depression, d is equals to ks plus c cos theta minus s2 sin theta. V is equals to ks plus c sin theta. Now the curves. There are 4 types of curves. Simple curve. This is the simple curve. Compound curve. Compound curves are the curves having different radius. This is curve 1 having radius r1. This is curve 2 having radius r3. More than one radius are there. Reverse curves. They are in the reverse opposite directions. This curve 1. This has radius r1 and this is in the opposite direction of this one. It is r2. That is what it is called the reverse curve. Next one is transition curve. Transition curves are generally introduced to join the tangent, the straight profile with the curves to gradually introduce the curve. These are the transition curves. This is the simple curve. These are generally used to join the simple curves from the straight profile. Simple curves. This is the general profile of the simple curve. Now we are going to study various properties of the simple curve. So we have to see this curve. The first one, basic parameters. The first one is length of tangent, T1b. This is the length of tangent, r tan theta, tan delta by 2. Next one is length of curve. This is the length of curve, 2 pi r upon 360 into delta. Now length of chord, T1d, T2, 2r sine delta by 2, T1d, T2. Apex distance VC, this is the apex distance. VC is equal to r sec delta by 2 minus 1. And the mid-ordinate, this is the mid-ordinate CD, is equals to r1 minus cos delta by 2. Now chainage at T1. Chainage at T1 is equal to chainage at V minus T1B, that is length of tangent. Chainage at T2, chainage at T1 plus length of curve, this plus this. Degree of curve for 30 meter chain is equals to 1718.87 upon r, but generally we use 1720 upon r. For 20 meter chain it is 1150 upon r. Intermediate chord lengths are: first chord length C1 is equals to multiple of one chain length just greater than chainage at T1 minus chainage at T1. Last chord length chainage at T2 minus multiple of one chain length just less than chainage at T2. Now length of all other chords is equals to one chain length. Number of intermediate chord, this is one is important, and is equals to L minus C1 minus C1 minus Cn upon one chain length plus 2. Now these are the methods of setting out the curves, means to how to draw them. There are 4 methods. First one is perpendicular offset method. O1 is equals to r minus under root of r square minus x square. This is the exact relation, so not so important. O1 is equal to x square upon 2r. This one is important. It is used in the MCQs. The second one is radial offset method. In this also, coordinate is equals to under root of x square plus r square minus r. Exact relation, and we have to remember this one, x square upon 2r, approximate relation. Third one is offset from chord produced method. Nth offset equals to cn minus 1 into cn upon 2r plus cn square upon 2r. Here delta n is equals to cn upon 2r. Fourth one is tangential or deflection angle method or Rankine's method. Delta 1 is equal to 360 upon 4 pi into c1 upon r. After solving this we get delta 1 is equal to 1719 c1 upon r minutes. Delta n is equal to 1719 cn upon r minutes. Delta n is equal to delta n minus 1 plus delta n. Delta is the deflection angle. GIS, Geographical Information System, a system designated to capture, store, manipulate, analyze and represents represent all type of geographical reference data is called GIS. It represents the data in the form of layers. For example, roads, soil, resources, environment, trees, buildings. We can see all of them separately. Now the tools used by the GIS. First one is information tool. Information tools used are geographical data, remote sensing data, environment related data, hardware, computer, digitizer, plotter, software, AutoCAD, DBMS, GIS, overlapping device, multimedia, 2D and 3D photographs, and 3D modeling. Other names of GIS are EIS, RIS, and LIS, Environment Information System, Resource Information System, and Land Information System. Remote sensing. It is the technology for getting the information about an object without making physical contact with the object. It uses aerial sensors to detect the object on Earth's surface in atmosphere and inside the water bodies. Sensors used are active and passive sensors. In the remote sensing, active sensors are the one which emit their own radiations to monitor Earth's surface or atmosphere. For example, radar and laser scanner, they emit their own radiations. Passive sensors, they detect sunlight or thermal radiations reflected from Earth's surface. They do not emit their own radiations. Now, Global Positioning System, GPS. It is satellite-based navigation system made up of a network of 24 satellites placed into orbit by US Department of Defense. Number of satellites. Minimum number of satellites used for exact position are 4. Important. But we can use 3 also, but for approximate position. Name of the network, it is Navstar. Accuracy for military plus minus 10 meter. For civilians it is plus minus 100 meter. Height of satellite is 11,500 miles and the speed of satellite is 3.9 kilometer per second. So now that is all, friends. If there is any mistake or any suggestion in the video or for the video, then please do let me know in the comment section, and please don't forget to like, share and subscribe with your friends. Jai Hind, Jai Bharat.